Hello and welcome back. Today we've got an important tutorial. We're talking about feature scaling. Now, before we dive into the technical aspects of feature scaling, I would like to present you with an image that hopefully will help you remember what feature scaling is applied to. Now, even without knowing anything about feature scaling, please remember that feature scaling is always applied to columns. So feature scaling would be applied to this column, to this column, to this column, to this column. Feature scaling is never applied across columns, so you wouldn't apply feature scaling to data inside a row. Just to remember, feature scaling is always applied to columns. Now, with that out of the way, let's have a look at what feature scaling actually is. So there are multiple types of feature scaling, multiple techniques. We're going to look at the two main ones, normalization and standardization. Normalization is the process of taking the minimum inside a column, subtracting that minimum from every single value inside that column, and then dividing by the difference between the maximum and the minimum. So basically, every single value in a column is adjusted this way, and you will end up with a new column or an adjusted column with values which are all between 0 and 1. Standardization, on the other hand, the process is similar, but instead of subtracting the minimum, we subtract the average and we divide by the standard deviation. As a result, all of the values, or almost all of the values inside the column, will be between -3 and 3. If you have some extreme values or some outliers, then they can end up outside of these -3 and 3 boundaries. So that is normalization, standardization. In the practical tutorials with Adlan, you'll be looking at standardization. And for simplicity's sake, in these intuition tutorials, we'll have a look at normalization. So let's imagine we have a dataset where we have two columns, annual income of a person and their age. Just a simple dataset with those two columns. And again, for simplicity's sake, we're only going to have 3 rows. We're going to have a blue person, a purple person, and a red person. Now here is the data. We have blue person making $70,000 a year and their age is 45 years. Purple person makes $60,000 a year and their age is 44 years. And red person makes $52,000 a year and their age is 40 years. Now, the task at hand is going to be slightly different to the regressions and classifications that we've been discussing. The task at hand is to see which of the two people the purple person is most similar to, just based on this data. Would you say that the purple person is more similar to the blue person, or would you say that the purple person is more similar to the red person? This is more relevant for the clustering tasks or clustering algorithms that we'll be discussing in the following section of the course, but it is just such a simple illustrative example that we're going to use it here. We're going to talk about a bit about it here to show the importance of feature scaling. So once again, if you'd like to pause this video, please go ahead and try to see, would you group the purple person with the blue person, or would you group the purple person with the red person? And now let's have a look at it together. So let's look at the differences. The difference here in salary is $10,000 and here it is $8,000. And in terms of age, the difference between the purple and the blue person is 1 year, and between the purple and the red person is 4 years. Now, what can happen with unscaled features, as we see here, is that the values, the unit values of one column can be so much larger than the unit values of the other that it might overpower. So for example, we can see that the values of 10,000 and 8,000 are much, much greater than the values of 1 and 4. So we might make the erroneous conclusion that, okay, we're going to ignore values 1 and 4 because those are such small differences compared to 10,000 and 8,000. We're going to focus on these large of magnitude numbers, 10,000 and 8,000, and out of them, we'll say that the purple person is clearly closer to the red person because that value is 8,000. It's $2,000 less, or 2,000 units less than the difference between the purple and the blue person, and as a result, we would group the purple person with the red person. Now, we don't want this or similar things happening in our algorithms, and that's why we need to normalize variables, because we can't compare. Right now, we're comparing salaries to years. It's It's like comparing apples and oranges. These are not non-comparable things. What if years was expressed not in years, but in minutes? Then those values would be much higher, or in seconds would be even higher. And even if you have the same units of measurement, like dollars in two columns, they still might not be comparable because they're relating to different things. So it's important to scale your features. And so let's apply normalization. As a quick reminder, this is what the formula for normalization is like. So we're going to apply it to the columns one by one. So we're applying it to the dollar column first. After normalizing, our values will look like this. So let's go back for a second and go here. So I'll let you pause this video if you'd like to do the manual calculations. This is the result. And once we apply it to the years column, our values will look like this. Once again, from here, we end up here. And now we can compare like for like. Based on this image, based on this data, which do you think the purple person is closest to? Well, I think the answer is obvious. The purple person is almost right in the middle between the red and the blue people. They're at 0.444, whereas in the H column, the purple person is closest to the blue person. It's very clear. So there we go. That's a quick illustrative example, very simplistic, but yet illustrative example of feature scaling. And I hope you enjoy seeing that together with Adlan in the practical tutorials. On that note, I look forward to seeing you back here next time. And until then, enjoy machine learning.